Hello, students. I've got a couple more questions that came up out of section 6.3. So I'm going to go ahead and hit those and let's see how it goes. So hopefully answer all these questions. And let's see here. There's 6.3. Question 4. Oop, I missed it. I went a little too far. There we go. Sorry about that. Question 4. It says 4b. Okay, so 4b is the one with the rational numbers being multiplied. So let's take a look at that one. Let me zoom in a little bit more here. Maybe that'll help. There we go. So 4b. And let's try this one. So this is one where really the distributive properties, all the things being used. So just make sure you distribute across addition and subtraction like you're used to doing. And so this would be x over y times y over x. So I'd have xy over yx. Then the next one would be minus x over y. And then the next one right here would be plus y over x. And the last one would be minus 1. And so then up here in the front, using what we know about the fundamental law of fractions, this x times y and y times x, I could simplify because we have a common x and a common y. And so this really then turns out to be the number 1 in front. So you have 1 minus x over y plus y over x, and then a minus 1. And once again, use your simplification whenever you can. A 1 minus 1, just like the chips, this becomes a 0 pair. And your final answer, if you want to write it the quickest way, would be y over x, which is positive, minus x over y. And that would be, that's it. Yeah, that's it. That's the result. Could you get a common denominator? Absolutely. Would it help you do anything else? No, not really, because they're already in nice reduced fraction pieces here. So there you go. That is for B. B as in boy. Okay, we'll clear that one. Let's take a look. 6.3, number 15 is next. So let me jump over to number 15. Question 15. Okay, Jasmine's reading a book. She has finished 3/4 of the book. She has 82 pages left to read. Love these word problems. Let's take a look and see if we can figure out what's going on with Jazzy Jasmine. All right, Jasmine, let's see here. So, a couple ways to do it. So what I'll do is I'll start with a picture approach, and then I will show an algebraic approach. So she's reading a book. Got it. She has finished 3/4 of the book. Got it. Okay. So I'm going to break it into quarters, right? She has finished 3/4 of the book, and she has 82 pages left to read. So this little box right here would be 82 pages. How many pages has she read? Aha, interesting. So 82 pages is 1/4. How much has she read? This up here would have been 3/4. So if this is equivalent to 1/4, then you could multiply this by 3 and you would be done. So this would be 82 times 3 gives you 246. She's read 246 pages. She has 82 more to go. There you go. This question could have also been how many pages are in the book total. That's another one you could do. Okay. All right. Does that seem all right? That seems all right. Got it. So let's go the other direction. That would mean 82 is 1/4 of the book, right? Think of this as like a partition division problem, right? How many pages in the whole book? Okay. So that is basically 82 is 1/4 of what I need. How many is what I need? And this could be as quick as invert and multiply. And then multiply this and you get 328. That's how many are in the whole book. But you still have 82 pages to go. So if you take away 82, guess what you get? 246. So there we go. Let's see. If you were bringing in, I would also bring in section 6.4 here because to me that's the perfect choice. What do I mean by that? Give me a second. Let me go up here and throw in some white space. Okay. So What do I mean? I mean 1/4 of a book is 82 pages. So 3/4 of a book is how many pages? You see what I'm saying? Like just set it up as a ratio. And then you don't have to go. I mean, you could certainly go through and solve this by finding cross products and going that way. You could invert it and then multiply by 3/4. But you could also just pause and say to yourself, wait a minute, self. Scott keeps talking about that fundamental law of fractions. And if I look right here, I had to multiply by 3 to get that number. And if these are equal fractions, which they are, then I had better be able to multiply by 3 down here because that is the fundamental law of fractions. So the end result would be 82 times 3 is equal to x. And that also is the 246. So a couple ways to go about doing that. All right. There you go. All right, that is number 15. Let's take a look. Next up is number 19. Okay, let's scroll down. Let's see what number 19 has in store for us. Number 19. Ooh, a lot of options here. I'm not sure. The person didn't say which part might be the issue. And there are a lot of parts here. So I guess I could do a couple of them maybe, but yeah, these are just the exponent rules, and they're trying to not really give you a curveball, but make sure you understand. Like for this one, for part A, you want to subtract exponents, you got to have the same base. Okay, you got to have the same base. You do not have the same bases over here, so therefore this one would be false. And you could give an example of that if you wanted to. 3 to the 5th over 4 squared, right? That's gonna be a big number over there. And over here, is that the same as 3/4 to the 3rd power? No. If you look, first off, on top, you'd have 3 cubed, which is not the same as 3 to the 5th. So right off the bat, you'd be able to say, no, that doesn't work. Okay, so that's why that one fails. Now let's see here, AB to the minus M. So then now use what you know. AB raised to the minus M would be the same as 1 over A times B, and that whole thing to the M. And then remember, an exponent like this would be AB times AB times AB times AB M times, which is the same thing as A to the M B to the M, because again, you're just kind of using that idea of an exponent. And that actually does work out to be 1 over A to the M, 1 over B to the M. And so that, I would say, is true. And it's true all the time. Again, they did put some conditions up here that A is not 0 and B is not 0, so I don't have to worry about this thing turning into an undefined situation. Okay, anytime you have some of these craziness, I'll skip to D. I'm not going to try to do all of them here. That again wasn't really the goal. But anytime you have something like that, you could write 2. I have A to the minus 1 plus B to the minus 1 to the minus 1. Okay. All right. That's a lot going on. Start with what's inside the parentheses. Just simplify it. Just make your life easier before you go too crazy, right? So this would be 2 times 1 over A plus 1 over B. And I know the whole thing's being raised to the -1 power, but let's get a common denominator and see what happens here. Okay, so this becomes 2 times B plus A over AB. If I'm going too fast for you, just fluff away so that you can get down to where I am. Okay, to the -1. And then think, what does that -1 power do? Remember, -1 finds the reciprocal. So I have a fraction here. So the reciprocal of that would be AB over B plus A. There it is. And to be to the positive for 1 power, which is basically keep the number itself. And then take a look. This compares very nicely to that. And that is happiness. And that is always. Okay. All right, there's 19, and then MC number 8. Oops, let's see here. MC number 8. Delete. Clear all my drawings. MC number 8. Let's take a look. MC number 8 is the word problems. So not sure when to use multiplication and when to use division. So again, so kind of what I was saying in class today, hopefully that helped a little bit. But again, if you had 3/4 of a package of sugar fills 1/4 cup. So 1/4 cup is 3/4 of a package. 1/4 cup is 3/4 of a package. How many cups are in a full package? So they're asking, can you solve for P? This would be fraction division. So 1/2 divided by 3/4, that's how you get to P. Again, thinking of multiplication and division as reciprocals, inverse operations. Okay, let's go up here. It looks like there's some other pieces to it. How many packages are needed to fill? 2 cups. Okay, well, yeah, if I was doing that one, I'd probably set it up as a ratio if you want to be perfectly honest, because that's not exactly division or multiplication. Let's see here. If 1/3 cup of sugar is required to make 2 loaves of challah, so 1/3 is 2 loaves of challah, how many cups of sugar are needed for 3 loaves? So again, this is not really technically multiplication or division. Although you could view it, if you think of it with proportional reasoning, you could think of it as if this is worth 2 and I need to get to 3, I need to multiply by 3/2 to build it up, to scale it up. And then you could multiply this by 3/2. Okay, so technically multiplication, but not in a really nice way. Probably what people would do is they'd take the 2 loaves, divide this whole thing in half, so you know how much is in 1 loaf, and then multiply by 3. Let's see here. 3/4 cup of sugar is required for 1 gallon punch. How many gallons can be made with 2 cups of sugar? Yeah. Again, yeah. I don't know that I would say that any one of these was really multiplication or division, because what we're doing is we're scaling up in such a way that we're not doing pure division to get there. So E, if you have 22 3/8 inch ribbon, you need a 1 1/4 inch to decorate 1 doll. How many dolls can be decorated? Oh, hallelujah. Repeated subtraction. This is definitely a fraction division problem right here. So that's it. So I would not be giving you a question that kind of mixes like this, because that really is a ratio. This much for 2, how much for 3? Okay. If it was purely division, partition style division, it would say how much is in 1 loaf. And then it would be partition division. When it says how much is in 3 loaves, I have to do partition division, and then I have to multiply. I have to scale it up. Okay. All right. Well, that's it for this one. Hope it worked out. Hope it helps. Off you go.